So in this section of the course, we're going to talk about load balancing. Now there are two kinds of load balancers within Microsoft Azure. The load balancer is called a level 4 load balancer, and there's another one called application gateway, which is a level 7 load balancer. Now these have got a lot of things in common, but there are some differences. In this video, we'll talk about load balancing, and we'll talk about application gateway after that. Now, what is load balancing? Now, basically, load balancing is the concept where you have traffic that is coming in from another source. So that in this case, it could be the internet, or it could be from another application elsewhere within your Azure network. Traffic is trying to reach one server, but instead of having a single server doing all the work, you've decided to distribute the load across multiple servers, 2 or more servers doing the same job. The load balancer is what does the distribution to ensure that one server doesn't get overwhelmed with all of the traffic. Now in this case, the load balancer, which is the level 4, only makes those determinations based on 5 factors, which are the source IP and port, the destination IP and port, and the protocol. So based on those factors, it can decide which backend pool is going to be the one to send traffic to, and out of those it's going to use an algorithm to distribute the load based on some algorithmic way. Now that means that the load balancer is a fairly dumb device. There's not a lot of intelligence here. It really is just someone comes in the door, sends them to server 1, someone comes in the door, sends them to server 2, someone else comes in the door, sends them to server 3, and that's called a round robin algorithm. There are other ways of handling this. Now so that's one of the benefits of a load balancer, is it basically is able to distribute the traffic that would normally go to a single server into multiple servers. The other benefit is that it is able to detect if something goes wrong with any of these servers and basically drop it out of the rotation. So let's say at some point server 3 stops responding. We send it traffic, and then a timeout happens and it never returns with a response. We can then make that determination after 1 or 2 or more failings that server 3 is dead, and we can basically just cut it out and only send traffic to server 1 and 2. So not only does it distribute the traffic, but it also monitors the health of the recipients and can then cut them out of the rotation when they are no longer healthy. Okay, so that is the primary function of a load balancer. We go into Azure. Under networking, we can see that we have these options. Let's create ourselves a load balancer. Give it a name, AZSJD new LB, classic name for a load balancer. First decision that we have to make is whether it's a public or a private load balancer, external or internal. Now, a public load balancer has a public IP address and a public name. That means that it's addressable from the open internet. If we made it an internal load balancer, it has a private IP address, does not have a public IP address, and is absolutely not addressable from the open internet. Okay, so if we want a public load balancer, then we need to create a public IP address. So let's give the IP address a name, AZSJD new IP, and we just want a basic address. We do not need a static IP that never changes. We are fine with an IP that will occasionally change because we're going to use the name of the IP address, the domain name essentially, to address it, not the IP address itself. We can optionally choose an IPv6 address. Within Microsoft Azure, the load balancer is one of the few devices that supports IPv6. So if you have an application that you need to work over IPv6 and need an IPv6 address, then you are forced to put a load balancer in front of it. So even if there's only one virtual machine, you would put a load balancer in front of that to be able to create a v6 address. Then the load balancer is going to address translate from the v6 address of the load balancer into the private IP addresses of the machines behind. Use my usual subscription. I created a brand new resource group For this, I call this New York app. So I'm going to create this load balancer as the first resource inside of my New York app resource group, and let's leave it into East US 2. Now, while we're waiting for that load balancer to be created, we did notice that Azure gave us the choice between a basic and a standard load balancer. Okay. Now, their standard load balancer is a relatively new feature set within Azure, and basic is the default, but you can choose standard. Let's look at this web page that shows you the difference. So basic load balancer supports up to 100 instances behind the scenes, whereas a standard one 10x's that to 1,000. Okay. By the way, this table formatting is a bit skewed, but that's not my fault. Within the standard load balancer, we can address any virtual machine in a virtual network, and it could be a blend of virtual machines, availability sets, and VMSS scale sets. Whereas for the basic load balancer, you get the choice of a single availability set or a single virtual machine scale set. Okay. It does support HTTPS traffic in load balancing in terms of health probes. I guess if your web app or your website only supports HTTPS traffic, then you are forced to use a standard load balancer. It does have some additional stay alive options for the health probe. It supports the new availability zones. We haven't talked about that yet, but it's another way that applications can be distributed for a high availability scenario. Standard load balancers can support that. Basic load balancers cannot. We've got the ability of Azure Monitor, which is Microsoft's new monitoring dashboard. We can now pull in login events from this load balancer into that. Secure by default, so load balancers, basic load balancers are default open, and you would have to then set up your network security group to shut down traffic to load balancers, whereas you would need whitelisted. It needs to be whitelisted in order for traffic to come in. This is the new thing for a lot of resources. Blocked by default, denied by default, as opposed to a few years ago when a lot of things were open by default. Okay. So we can sort of see on this type of page that there's some very advanced things in terms of different outbound rules, basically allowing traffic to be sent outbound based on IP addresses or public prefixes, etc. Okay, management operations are a lot quicker. There's an SLA. The SLA here, remember in virtual machines, the SLA is 2 or more virtual machines, 99.99%, whereas the SLA is on the load balancer itself here. Okay, and the pricing is more complex pricing, whereas basic load balancer is free. So you do have some decisions to make. It pretty much in a production environment, you probably want to pick the standard load balancer. Simply because it has an SLA, although you have to investigate the pricing for that. So we can see that our load balancer got created and our public IP address associated with that load balancer. Let's go into the load balancer. Now, we've only created a load balancer, but we haven't hooked it up with anything. There is no servers, there's no backend pools, virtual machines that are waiting to receive traffic. We haven't set up the health probes in order to determine if those servers are healthy. So what I'm going to do is I'm going to create 3 virtual machines and an availability set. And then we're going to show you how to add that availability set to this. Again, it's a basic level, basic SKU load balancer. So we're restricted to only virtual machines, individual virtual machines or virtual machines and availability set. So I'm going to pause this and create 3 virtual machines and availability set. All right, so I've created 3 new virtual machines in an availability set. Let's add this to the load balancer. So we go under Backend Pools and we say Add. We have to give it a name, so AZ Load Balancer Backend Pool. IPv4, and it's a matter of associating it with one of three things. Now I can associate it with an availability set, which is what we're going to do in this case. We can associate it with a single virtual machine, which then we'd have to do it multiple times for the load balancer to have multiple virtual machines. Or we can associate it with the virtual machine scale set. Okay. Remember, we saw in the basic load balancer, you can only choose one of these options. So the question is, what availability set? Now, the availability set must exist within the same region as your load balancer. It makes sense because if you think of your load balancer as running on a server within East US2 region, you want your virtual machines also in East US2 region. Don't have your virtual machines in Europe while your load balancer is in the United States. That's going to be a very high latency, slow thing to do, and obviously Microsoft doesn't even allow that. So the availability set must exist within East US2. And we're not done yet. We still have to add the virtual machines inside of this. Okay, so we've got our availability set, and now we can choose our virtual machines. I've created AZ VM1, VM2, and VM3. There's one network interface card on each of those, and so we're going to choose the one network interface card. We're going to go to the second virtual machine, choose that network interface card, and the third virtual machine, and the third network interface card. Okay. So now we have, I have to click that, but let's do that. All right. Now we have three virtual machines that were in availability set that are going to be part of our backend pool. Let's click OK. I guess it doesn't like that, so let's delete that. Click OK. That's going to take a few minutes for this backend pool to be constructed. Now while that's running, we can see that it's some deployments are going on here. We'll let that run. Let's talk about health probes. So we're going to go on to the health probes section. Now remember, we said that load balancers, they're pretty dumb machines, except they do have the ability to check on the health of the virtual machines in their backend pool. And then if they detect one is not responding within a reasonable time, then it will kick that machine out of the virtual backend pool. Okay, so let's create a health probe. Got to give it a name like usual, so let's call it health. It's IPv4. Now the health probe can either check on the status of a port. So in this case, it's just going to ping port 80 over the TCP protocol, and then every 5 seconds in this setting, every 5 seconds it's going to touch port 80, and if it fails to open port 80 twice consecutively, so it takes about 10 seconds of failures before it says, unhealthy health probe has been triggered. Okay, so this is within 10 seconds, this will detect that port 80 is no longer opening. Another popular way to do that is based on HTTP probe. So even if port 80 is responding, that doesn't mean that your application is healthy. Okay, so you may want to pull in the web page that's at the root, the home page, if you will, and then if it's able to get a 200 success code from the home page, then that's considered a healthy probe, or 2 consecutive failures to be unhealthy. A lot of people will create a standalone web page like health.htm or probe.htm, where you can make this part of your application, and so that you're not pulling down your home page, which might be a fairly heavy page and might cause your application some performance concerns if you're hitting that home page every 5 seconds. And so creating a standalone page that is simply for the health probe to check on the status might be a smart alternative. Okay, so you'll see that there's pros and cons to checking just the port, or checking the application, or having some kind of proxy page that is designed to fail if your application isn't up. Now be careful, obviously with an HTML page, that could very well continue working while your home page is not responding, or while your .NET application is not responding. So there's some strategy in terms of choosing your healthiness. Let's change it to the TCP probe so that it doesn't matter what application we have running, as long as port 80 is responding, then we are considered healthy. Actually, yeah, considered healthy. I haven't enabled 443 for those servers. Okay. So now we're creating a health probe that is simply it's simply going to be happy if port 80 is responding. Now for these virtual machines that I've created, I actually haven't logged into them to set up IIS, to set up web servers on them. I haven't added the web server role. So I imagine port 80 is going to fail. So while we're waiting for this backend pool to finish updating, while we're waiting for the health probe to be created, we know that these servers are not going to respond on port 80 because I haven't set them up yet. Okay, so I would expect all 3 servers within 10 seconds of them being live to basically be kicked out of the pool because they are not responding on port 80. All right, we have our server set up. We have our health probes. Now let's set up the load balancing rules, because as it stands right now, this load balancer isn't configured. It doesn't have any rules, and so we're going to have to create one. So at least one set of load balancing rules. So new rules. So it's an IPv4 load balancer. We've got our IP address, which is load balancer front end. We are accepting traffic from the public over port 80. We are sending traffic to the other VMs over port 80. So there is the possibility of what's called NAT, or net address translation, network address translation. So we could have port 8080 set up on the VMs, and then the load balancer handles the public port 80. That would be a security setup, but we're going to leave it as a pass-through where port 80 comes in and port 80 goes out. We've got our pool, which is the only pool we've set up, the 3 virtual machines. We've got our health probe, which is the only health probe that we have. We do not support sessions, and so each client that comes in is going to be put to a random virtual machine. We're not going to then send the same client to the same virtual machine. We could, of course, say the same IP address always goes to the same virtual machine if we wanted to enforce have sessions, but in this case we won't. And basically we can ignore this idle, we can ignore this IP address and say OK. And this is basically what is required between the backend pools, the health probes, and the load balancing rule in order to get this load balancing working. Okay. So once this rule gets deployed, then we're going to have a working load balancer. So right now we have a basic load balancer that has a single public IP address that is sending traffic to this set of virtual machines, has a health probes, and we have a single set of load balancing rules for port 80. Okay. Now there are times when we have our virtual machines with more than one type of application running on it. So we can actually create another public IP address on the same load balancer. So let's add the second load balancer IP to this load balancer. We're going to choose from our existing public IPs. I created a public IP called second IP, and we're basically going to say the second IP is now assigned to this load balancer. Okay, it's going to take a second to update, but we don't have any rules defined for that IP address, so right now the load balancer wouldn't know what to do with that traffic. Again, it wouldn't be configured yet for that traffic. Let's assume though that we're going to leave that backend pool the same. We're not adding any new servers. These 3 virtual machines are still the virtual machines that are going to respond to all traffic. We go down to load balancer rules, and we're going to add a second set of rules. Now this is second rules. Give it a unique name here. Now instead of using the default IP address, we're going to use the second IP address that we created. Now, since we're sending traffic to the same backend pool, we probably don't want to, we can accept traffic on port 80, but we probably want to use a different IP address port for that. So if we were to go into the 8080 port, then we can have two applications running in our virtual machines, one responding to port 80 for the other rule, and a different application set up in IS responding to port 8080. Okay, so using different ports allows you to have multiple web servers essentially responding to traffic for the same IP address. Now, we pretty much could rely on the same health probe if we wanted to, but since we're using a different port, we probably should create a new health probe for port 8080. Okay, and if I could do that, but I won't. But basically, we would want a second health probe for the second application. Same settings in terms of sessions and timeouts, etc. Hit OK. And now we have a single load balancer that's accepting traffic from two IP addresses, two unique domain names, for instance, and sending this traffic to the same backend servers using different rules. So accepts it on port 80, sends it back on port 80. The rule that's being updated now accepts it on port 80 for a different IP address, but sends it to the backend pool over port 8080. And so we can see that we can have multiple rules in the same load balancer, basically handling all traffic going to this backend pool. Now we really wanted to get fancy. Now in the basic load balancer, we can only support this one backend pool. In a standard load balancer, it allows us to have a mixture of virtual machines and other devices, remember. Okay, so this is the top level overview of a load balancer, which again, it's only handling IP addresses. You'll see that we did not have the option to configure based on URL, domain name, path, anything like that. Purely doing traffic filtering based on IP addresses and ports. The application gateway is what allows us to do that higher level traffic. All right, so I'm going to delete this load balancer and we're going to set up an application gateway instead. This way, we can't have a load balancer and an application gateway pointing to the same set of backend pools, right? So let's close this out. We're going to go back into the marketplace, go back into networking, and we're going to look at the second option here, this application gateway. Now, like I said, an application gateway is similar to a load balancer in that it distributes traffic between two or more servers. But in the case of an application gateway, it's a more sophisticated device. I would consider this to be an intelligent device as opposed to the dumb device that a load balancer is. So AZSJD, new application gateway. Now, we do get some sophisticated options when it comes to pricing. The standard gateway is just like a load balancer. It provides load balancing features. You also have the web application firewall, which has the gateway plus a more sophisticated firewall option as well. Let's just stick with the standard gateway. Now, do we want to have manual or auto scaling? See, right away we can see that we are being given more sophisticated options for scaling our application gateway than we did for load balancer, which is just a single device. So now we can have two application gateways that can grow based on demand, essentially. Let's put this into our New York app resource group, East US, because remember, the load balancer has to be in the same location as the virtual machines. Now, the application gateway gives us this concept of availability zones. Now, we haven't really talked about availability zones yet, but availability zones is a way of distributing multiple devices, in this case application gateways, into specific data centers. So instead of just saying it's East US 2, then we can go Zone 1, Zone 2, or Zone 3. Now keep in mind that not every region has availability zones. So I go into Canada and availability zone is blocked out, okay? But if we go into Central US, it's available. If we go into East US, it's not available. East US 2, it is available. This is, when I was at Microsoft Ignite, the rollout of availability zones is a lot of very hard, difficult work for Microsoft. So they basically got to change out the whole way that they do networking behind the scenes in order to be able to handle this type of functionality. I'm not going to choose availability zone. I'll let Azure deploy this application gateway into whatever data center it thinks is most appropriate. But if high availability is our goal, we're going to have to specify one goes into one zone, another goes into another zone, etc. Okay. So I'm going to click OK, and we're going to get on to the next set of settings. We need to put our application gateway onto a virtual network. Okay. We might have to create a new virtual network for this new virtual network 2. It's going to put it into the 10.2 space. We're going to have to create a default subnet along with that. New virtual network is going to be created. Now we still have the same distinction between public, external load balancing and internal private load balancing. Okay, we're going to leave it as public. Do we have the option to create an IP address? And so we're going to let it create a brand new public IP address. We can get into the settings if we want. We can even give it a name. So let's call it AZ new availability application gateway. So this load balancer can basically have a name. Now, of course, we can set up custom DNSs so that this is a friendly name for our users. We're going to listen on HTTP port 80. So right away we can see the application gateway is talking about protocols, HTTP and HTTPS. So this is more aware of what we're doing with the traffic as opposed to being fixated on port 80. We can have HTTP2 enabled or disabled. We don't have the web application firewall set up. Of course, we could have chosen that tier. We can, again, Microsoft's giving us a second option to upgrade to the web application firewall. Let's say OK. We get the options to review what we are getting signed up for, and then we'll click OK. So now we're going to wait for it to create us our application gateway. All right, so we're back to our application gateway. And let's go into our backend pools. Now remember, when we were setting up our load balancer, we had to basically set up an availability set into our backend pool. We have a default backend pool that Azure is giving us here. We go into it, and there are no targets associated with this. Now the really cool thing is that we can now target IP addresses or fully qualified domain names as our backend pool. This allows us to have Azure be the load balancer and have the servers themselves hosted elsewhere. So we can have, Amazon AWS servers that are hosted in Amazon, but using the load balancer from Azure or from our own on-premises environments. Now this isn't necessarily smart because there's some lag time and some latency introduced, but basically we can have any device that responds to an IP address be behind our application. We obviously want to deploy this to our virtual machines. We still have the virtual machine scale set option. We also have app services. So if we wanted our application gateway to be the front end to a number of app services, we could. Now remember, app services normally have their own load balancer built in. If we had 2 or 3 instances of an app service, then the load balancer is taken care of by the app service. But if you had several app services that are all having the same function hosted in different areas of different regions, for instance, then you can put a application gateway in front. Let's choose virtual machine. Now, in order for us to choose virtual machine, it has to be virtual machines running in the same region and also on the same virtual network as our application gateway. you'll notice that even though we set up our virtual machines in an availability set, we have the option of choosing them individually. So we don't actually pick the availability set. Unlike the load balancer, we are just picking the virtual machines and we're picking their network interfaces. Now I'm going to say save. And so now I'm adding 3 virtual machine targets into the backend pool. Now in terms of our IP configuration, remember we have a public IP address associated with this. And so it's basically, if we have any traffic that comes in over this IP is going to be distributed to our backend pool. The application has a listener set up, so it's listening for traffic over port 80. And it's going to use rule 1. Go back into the rules. And what we have here is basically a basic set of rules. Let's add. You see here we can have basically just all traffic over port 80, or we can have this additional thing called path-based. Now this is, again, that sets application gateways apart. We can create new rule. We don't have any unassociated listeners. We'd have to create that. But basically we can start to say that anything that comes into /API gets sent to one set of servers, and anything that comes into /images gets set to a different set of servers, and anything that comes in to the root will get set to a different set of servers. So we can set up a more sophisticated set of logic that will redirect traffic to different sets of servers over different rules. Okay, so this is how path-based rules work in application gateways, and this is one thing that makes application gateways completely different from load balancers.
In 2019, Azure introduced a brand new service called the Azure Front Door Service. Now, as the name kind of implies, this is a technology that runs like a load balancer, but at a global scale. And so instead of having regional load balancers and regional application gateways, what we have here is a global load balancer. Now you might say, oh, doesn't Azure Traffic Manager perform this? Well, yes, it kind of does. But Traffic Manager is a DNS hack. It's not a real load balancer. Front Door is a real load balancer. It also has a CDN built in, so it has an acceleration platform, they're calling it. It has a SLA, so it's highly available service. So really, and can combine app services and virtual machines, and you can put a lot of stuff behind the Front Door service. So let's start and create one. So we're going to click the Create button. Now the Front Door service is a global service, but it does need to live in a resource group, and so that resource group has a location. I'm going to say Azure My New RG. I'm going to create a brand new resource group for this. And I'm going to place the resource group in the central US location. I'm going to go say net configuration. Now we do need to set up the Front Door service before we can create it. And if this interface looks very familiar when it comes to setting up a load balancer or an application gateway. You need a front-end host, which is the IP configuration. You need a back-end pool, so that is going to be some services to send the traffic to, and you need a set of rules to dictate how traffic gets routed. So let's create a front-end host, and in this case, the front-end host is just a DNS name, which is going to end in .azurefrontdoor.net. So Scott's first front door .azurefd.net. Now it has to be unique across all of Azure. Now, do we want to force users, once they go through the Front Door service, to go to the same set of servers every single time? That's called session affinity or sticky sessions. Let's say that's disabled by default, and we're going to leave it unless you have a really good reason to force users to the same application backend. We also have a web application firewall. And so if we're talking about application gateways, you'll know that a firewall is an optional feature. And so it can run the traffic that's running across the front door through a basic set of filters to make sure that you're not being hacked. There's no cross-site scripting or SQL Server injection, etc. So that costs money, but we're going to leave that disabled. So the host is pretty straightforward, right? It's basically a name. Now, where are we going to send this traffic? Now, we can create what is a backend pool, very much similar to Load Balancer. Now, the backend pool can be a number of different types of things, not just virtual machines, but app services as well. So we're going to give this a name, call it backend 1, and we're going to basically have to add a server to accept the traffic. Now, what type of server? We can see that we can have an app service, Azure App Service. It can be a storage account. It can also be an IP address. So if we have a server that's running in AWS or running in our own environment that has a publicly facing IP address, then we can set that up as well. So it works just like an application gateway in that respect. Now, for this application service, I can choose, my subscription. I can choose from my options. I've got a couple of WordPress options here. Let's say that I'm going to choose this one. And again, it can handle HTTP, HTTPS traffic. We can set priority. So if we have multiple backends, one backend is a primary, one backend is a secondary, or are they equal priority, etc. And how are we going to distribute the traffic? Is it 50-50? Is it 90-10? You can basically define how that gets distributed. And of course, it's enabled by default. I can also add a second backend, choose App Service, choose the other WordPress account. Now, these are different WordPresses, but that's let's say that they're the same. And so now I have two app services that are 50-50 going to receive traffic from scottsfirstfd.azurefd.net. Now, just like an application gateway, we can set up a health probe, and it's going to try and ping a HTTP web page and determine the status. It has to come back as a successful status, and we'll do that every 30 seconds, and we can do that over HTTPS. The load balancing settings will basically allow us to, whether we're going to have how many of these health events are going to have to fail in order for it's going to be considered failed. So 4 events over 30 seconds is about 2 minutes. If we get 2 successfuls, that means it's a healthy backend. Okay. So now we've added the front end, we've added the back end. Now, how are we going to distribute traffic? Now, in this case, we only have the one back end. So 100% of that traffic is going to go to that back end. So the back end rules, the routing rules should be, 100% goes to one back end. Now, if we had like /images or /videos or we had different host headers, different domain names, we could play some games here and send traffic to multiple backends. Very much like our application gateway. So do we forward the traffic or do we redirect the traffic? Redirecting, of course, is more permanent, whereas forward, this means that this is intercepting the traffic with every connection. And we won't do URL rewrite, etc. We can turn on CDN. So basically, all static content can be cached. Okay, and we can even turn on compression, like I said, like CDN, which will allow it to compress traffic, gzip compression over HTTP, which will reduce the amount of bytes being sent to the end user. And so there we have it. We just set up an Azure Front Door service. We can add our environment equals dev tag if we want, or however. We can click review and click create. And if we did this, then this traffic is going to basically distribute traffic 50-50 to the 2 WordPress blocks that I've set up.